last bit I don't remember. So hello, good afternoon, or maybe we are closer to good evening now. My name is Rajesh Sahasrabudhe. I'm working with Rezoomex. We have a stall here and some cool NFTs you can make. More about that later. So. So Hyperledger Fabric chain code, writing ERC compliant smart contracts using Golang. Sounds very complex and boring, right? But particularly this time of the day, but it shouldn't be, as you will see in the further slides. So let me start with a typical myth which goes on in this blockchain world. So obviously I'll come to the part of where Golang fits and where what is ERC20 and all. But to start with, so this is a typical myth that like this happened with me also a few years back when I got into blockchain. So when I say that I'm in blockchain to anybody, people used to actually run away from me saying I'm doing कुछ तो illegal कर रहा है and you should be away from me. So but obviously things have changed now. So as I say, like this conversation always starts in a wrong way. So what is the right way? So welcome to the Web3 world. There are so many things: blockchain, cryptocurrencies, metaverse, NFT, gaming. That's now again. So all of this we won't be covering, of course. It's only the blockchain part which I'll be talking about. So just back to that previous slide. Blockchain is a application of. Actually, it is an application of decentralized applications. Then crypto is an application of blockchain, and Bitcoin is an example of crypto in very simple terms. Okay, so we shouldn't be confusing all these things. So where Golang fits in, right? So in blockchains, the most popular ones are Ethereum and Hyperledger Fabric. Mainly in the public blockchain space it is Ethereum. In the permission blockchain space it is Fabric. And Fabric is very popular. I would say maybe it is even more popular than Ethereum for the reason being it is actually used by enterprises. It is permission. So unlike public blockchains where you do not know who is the next guy sitting next to me but running another node, in permission blockchains actually people know each other. And there are many other advantages. So Fabric is the very commonly used blockchain it is an enterprise grade blockchain. And so where Golang fits in is the program. So Fabric offers multiple languages for writing smart contracts, and Golang is again the most popular among them. Again, there are obvious reasons that the native language of Fabric itself is Golang. A lot of Fabric stuff gets released in Golang. And Golang is like, as you all know, it's very powerful, lightweight, very fast. So for such reasons, it is a very popular and commonly used language for writing smart contracts. So this session I'll just briefly cover initially a little bit about blockchain again, the concepts. Then what is Fabric, what is chain code, the topic ERC20. So what is ERC20, and finally I'll do a simple use case where I'm transferring a coin from one wallet to another, which is what probably mistaken as I'm transferring to him, but it's not Bitcoin, and I'm not transferring to you. Okay. So just a brief history. It all started in 2008 with Bitcoin. Satoshi is an anonymous person, nobody knows who he is, but he was the pioneer. It is a peer-to-peer application, but obviously it has limitations like the TPS is too slow. One transaction in Bitcoin network commits after 10 minutes, which is totally not acceptable in today's world. So Bitcoin is actually, so they don't use it for any applications, they use it like gold, store of money. So as you know, people buy and sell Bitcoins to make money. That's it. There are some age-old NFTs, they are again valuable. They get sold for millions, and again, it's a crazy market, but that's it about Bitcoin. Then the game changer was Ethereum, because the shortcoming of Bitcoin was, as I said, like it was peer-to-peer, it had all the basic properties, but nobody could develop anything, because who can agree with a 10 minutes TPS? So Ethereum came in. So Vitalik Buterin is very, I think, so he is very well-known personality, he comes in media and all. So people know him. This was a game changer. The reason was we were able to build on Ethereum platform. He provided EVM, which is the Ethereum virtual machine, and it had all these utilities. So that's his decentralized applications, DeFi, finance. So a lot of applications, coins, etc. are on Ethereum. So you can actually do trading in Ethereum network for different coins and make money if you trade right. So Ethereum was popular, and then there are a lot of use cases. So blockchain is a growing field. So fintech, insurance, many use cases. So finally, what is blockchain? So again, this is a very easy, simple diagram. In reality, there are thousands of lakhs of nodes. So essentially, it is nodes. Okay, so a node you can imagine as a person. Like I can run a node on my laptop, or you can run, or there can be organizations. Typically, there will be organizations who will be running nodes, but individuals also can, and they do. So as you can see, how this is different than a centralized or a client-server architecture. So client-server is a star topology, right? So you have a server, and then there are clients, they are connected to that central server. The problem here is anything goes wrong with that server, that entire network dies. Okay. Here, the obvious advantages of being so, there are three main things: decentralized, and it is trustless, and distributed. So distributed means these nodes can be really geographically distributed also. I mean, it is not necessary that all the nodes will be in Pune. They never are. Okay, so they will be in different places, which is actually useful, because again, obviously the standard fault tolerance and the standard properties of the network will not die, because they are geographically at different locations. Decentralized means, again, a very important aspect of blockchain. Every node will have a copy of the ledger. So ledger, you can consider it as the entire database. So the entire Ethereum network, today it is in some millions, billions of bytes. So it is on every node. Okay. Again, the advantage is if any node dies or any node behaves wrongly, okay, or they want to cut off a node, or a node is simply switched off, not available, the system will still work. Whereas in a client-server system, if the server is down, the entire system goes down, right? So these are the advantages of blockchain, which I think I've just briefly covered here. So decentralized, distributed, trustless, again very important. These nodes don't have to know each other in public blockchains. So parties who don't trust each other can work together. You can write smart contracts, and they will execute. Transparent openness. So in blockchain, every transaction is open. So like let's say I have paid him a Bitcoin, that is available in the on internet in that particular blockchain's site. The only thing which you do not know is I paid to him, because it is only wallet to wallet transfer which is shown. So although it is open, it is still anonymous, because unless you know which wallet belongs to me, you will not know that I paid to someone. So these are some major advantages of blockchain. It is immutable append only because it is open, as I said, it is public. So you cannot dispute it. It is append only. You cannot go back and update any previous transaction. You have only append. Okay. I think these things I covered. System is always available. Digital ledger. P2P is peer-to-peer. Works on consensus is a very large topic. Basically, in short, what consensus means is how those nodes will decide when a transaction gets committed in the network. That is consensus. So there are various types of consensus, like proof of work, proof of stake, etc. Again, not today's scope. This is again just a summary of everything which I said just now. So timestamp. It uses cryptography encrypted. No mediator charges. The high availability is an important property. So again, this is a very simple diagram of how transactions get recorded in a blockchain. So normally, the first block is the genesis block. That is where the blockchain will start. So always so let's say first 1 to 10 transactions are we are storing them in this block. Then the next block is storing this 11 to 12, 20 the transaction numbers. That means once you create a block, you take a hash and you put that in the next block. So hash of previous block. So that is how these blocks get linked. It's like a linked list. Again, I'm just telling maybe 10% of what is it in detail. Again, not in this scope to tell a lot of details, but in short, this is how data is stored in a blockchain. Now the types of blockchain, which I think I covered in the beginning. So there are public blockchains, Bitcoin, Ethereum, public because anybody can join that blockchain. Then the private is typically in one organization. Mostly people use it for any testing, etc. Permission is very, like I said, this has become very popular because here you allow only certain members to join. So the joining to a permission network is restricted. Not anybody can just come and join. The consensus is determined by those members. And nodes are really, so actually all the nodes are known to each other, as I said earlier. So this is not a public blockchain where we do not know who else exists. Here everybody knows. And that is why it is more secure, it is trusted by organizations. So that so obviously these organizations may not trust each other. Like for example in a banking, so let's say consider an example of banks. Say there is a Citibank, ICICI Bank and Axis Bank coming together, forming nodes and working together. They may not trust each other, which is okay. But at least they know each other and together they can decide on consensus and finality and transactions. So hyperledger fabric, so there are many types of permission blockchains. Fabric being the most popular, most used, so which is why I mentioned it here. So now coming to the structure of Fabric. So typically, so being a blockchain, right? So as I said, it will have nodes. So again, at a very high level, what the blockchain, Hyperledger Fabric blockchain contains. The first 3 lines they talk about security. So before any member joins, you have to make sure that he has the right level of certificate authority and the list is maintained, identity management. So this is security part. Then there are nodes. There are 3 types of nodes in Fabric. Committing, endorsing, and ordering means committing nodes will keep the entire data, entire blockchain, the DLT, the distributed ledger. That is why they are so basically in the public blockchain you don't have such a distinction. Everybody stores everything. Whereas here they are allowed. So some organization might say that we don't want to store everything. We just want to execute smart contracts. So the endorsing peers are for executing smart contracts. So these peers will be allowed to run a program. So in blockchain, software program is called smart contracts. So these are endorsing peers. And then the orderer. Orderer is when a new transaction happens and it is to be committed to blockchain. The orderers will decide the sequencing because there will always be multiple transactions coming to the blockchain. So we need to sequence them in the right order based on dependencies. So that is the task of the orderers. And finally, chain code. These are so, again, obviously the blockchain will always have data and programs. So the programs are in, so that is called chain code. These are smart contracts. So here is where Golang comes finally. So they give you a choice of Golang, Java, and Node.js. Golang being the most popular one. Again, I'd say maybe 80% of the applications existing today in Fabric, they are written in Golang. So that's why Golang is very important in terms of chain code. So this last point is also important that Fabric has no native tokens. Unlike Ethereum has Ether or Binance Smart Chain has got BNB. But Fabric has no native token. It allows you to create tokens if you want. Else you can just use the blockchain features. So in Fabric, so unlike that the previous diagram I showed, so 4 nodes connected each other, Here you are allowed to create channels. So the nodes which want to work together can create a channel. So let's say this node 1, 3 and 4 are doing certain transactions together, so they form a channel. And let's say these two nodes want to do different types of transactions, they form another channel. So finally, this is where Golang fits in. Fabric chain code, so it's the most popular language, I said. So the smart contracts are written. So what are smart contracts? The parties who don't trust each other, they can enter into these contracts. They agree upfront on conditions, and when those conditions are met, the smart contract will trigger. So that's why it is immutable. You cannot dispute it once it triggers. One thing you have to remember while writing smart contracts is Turing completeness is required. Means this is very important. In blockchain, you cannot have a non-deterministic output. Because when the smart contract gets committed to the network, so I talked about those endorsing pairs, right? So all of them will execute, and only when all the results match, that transaction will get accepted to the blockchain. So if, for example, in Golang you have concurrency, right? So you can fire multiple Go routines, which is where you have to be very careful, because if you fire those routines and they run in different sequences, giving different output, then your program will get rejected by the blockchain. Okay. So again, there are ways to use it, because concurrency is very good, and there are ways to make it work in blockchain. Again, not a part of the scope of this presentation, but obviously I'm always there at the booth. You can always meet me for more info. So how do you write the Golang chain code in Fabric? So very simple steps. You first do the development, then you package it. Then you have to install it on every node. So as I said, blockchain will be governed by all the nodes. So you have to go and install it on each node. All of them have to approve based on a pre-agreed criteria. So let's say there are 5 nodes. I get the criteria could be 3 or 5. Okay. So if 3 or 5 nodes agree, then that chain code gets committed. That is okay. But then based on whatever it is, it has to be approved. Finally, you commit it to the channel, and then the program is ready to get executed. So the chain code consists of these interfaces. So in Golang, you have to implement at least these interfaces, which are used by the chain code. Now, what is important in blockchain is the context and the state of the blockchain. Means always, whenever transaction gets committed, the state of the blockchain changes. They also call it as height of the blockchain, so the height will increase. Okay, so whenever you are writing to blockchain, at a very simple level, you have to first get the current context, the current height, do your transactions, and put the context back into the blockchain. Okay, so there is a get state, put state, and you use these packages, Shin package. So for invoking a smart contract, a Golang program, you have to use invoke method. Init method is to initialize. So get state, put state, which I talked about the state. So it is a stateful database. So when you are importing, in the chain code, so obviously these are the standard Golang provided libraries, but you also need these libraries which are not provided by default. So you have to import them from the Hyperledger Reader. So this was briefly about Golang. Of course, I'll cover a little bit more also. Now coming to ERC 20 standard, which was like the topic of the presentation. So what is ERC 20 is, it is a standard for writing programs which are compatible with the using application. Because one example is earlier, before this standard came, people just wrote any functions, and then let's say there is a wallet which wants to find out how many points you have, or it wants to transfer a coin. So without having a standard, so let's say I use a function which is called transfer coin, and somebody uses a function which is called transfer underscore coin. Okay, the problem is then obviously how will that MetaMask, so MetaMask is one of the popular wallets, it will know that which one, so otherwise it has to keep a list of all the possible functions, which is the reason this standard came. So it is Ethereum request for comments, the most popular standard in Ethereum, and this standard has given you a set of functions, you have to only use them. Means at least those names. So of course you can write any function, any other functions, but for usage of any application or any wallet or anything which is ERC20 compliant, you have to have those functions. You can only read those functions. So some examples. Total. So like for example, total supply. So how many coins totally you have? Sorry, not you have. The system has. That is total supply. Balance of is how many coins are present in a wallet. Transfer. So I'm transferring a coin from my wallet to somebody's wallet. I use this function. So I have to code. So I have to exactly use these names. Okay. Then only any ERC20 compliant application will be able to understand them. So finally we come to a use case where, so as I said, like simple use case, we use Hyperledger Fabric blockchain. We create two normal wallets, user wallets. We transfer tokens, and then we create the tokens in that wallet. So this is, so first I'm writing the ERC20 function, create ERC20. So it is simply creating. So it's actually calling. So this stub is context. So so that is the parameter. So we anyway, so standard messages. The main thing here, put state. So stub is the context, as I said earlier, right? So the current state of the blockchain is stub. Put state will write to the blockchain and change the state. Okay. So what I'm writing here is the wallet ID and the token. So in blockchain, everything is written in JSON. So you have to convert it to JSON format and write. The balance of function will read. So here you are passing the parameters as which wallet you want to read. So that wallet ID is the first argument here. So here we don't use put state, we use get state. Because you take that wallet, so pass it to the blockchain, get. So stub is context, get the context. This will give you the result, which is the token, number of tokens, and you then show them. Okay. Again, then transfer function. Here we accept three parameters. The wallet from, wallet to, and number of coins you want to transfer. So here again there will be a put state. Okay, this is calling, so this function is calling the helper function. So once you have the parameters and you have validated it, it will call a helper function. And that helper function will actually do the transfer. And here there is a put state. So in put state you are again doing the same as changing the state of the database by committing this new data to the blockchain where you have transferred coins from one wallet A to wallet B. Okay. So finally I show how this. So this is just using. So in this application, the smart contract is in Golang, the API layer is in Node.js. So using Postman, I'm executing it. So this is the first thing where this tokens 10. So let's say the name of the token is Fabric, so I'm creating 10 tokens. So this is the first wallet I'm creating. This wallet has got 10 tokens. So once it executes, it gives me the wallet ID, that is this last. Then I'm creating another wallet. This is second wallet. That wallet ID of it. So again, this is a very large number. Typically, it uses the SHA-256 and those algorithms. So now I have two wallets. The first wallet had 10 tokens. The second wallet had 20 tokens. Then I'm using this function which transfers, right? So from this first wallet to second wallet, I'm transferring 4 functions. Essentially, this is Node.js. It is calling that chain code which I showed before. So once you transfer it, I'm just showing this message, ERC20 tokens transferred 4. And finally, when I again go and read, so that balance of function will be shown, right? So I'm calling that function to read from that particular wallet. So because it transferred 4, now it is showing 6 as the balance. Yeah, so this is it. So this ends my demo. Yeah, this shows the second wallet where the tokens was 20, now it says it is 24. So 4 tokens have been added. Yeah, so with this we complete my demo. So as I said in the beginning, so I work for Rezoomex. I'm looking after the blockchain and NFT marketplace of Rezoomex. And this is some brief details about us. Our founder, he was in the panel earlier. And so we have a booth here. You can visit. We have got some cool NFTs, avatars, and you can also go to this link and mint your NFT. Again, today after this, we are having a dinner with drinks, so you can mint your NFT and join us. Yeah, that's it.